All right, so I believe we are live. So, hello everyone. A very warm good evening to everybody. Thank you all so much for joining today. So, I welcome you all back to a very exciting and informative session, which we're going to have on a very special occasion, and that is National Science Day. Now, I'm sure people who are aware of National Science Day might be aware that it's actually tomorrow, that is on 28th of February. But uh, since it's already late evening today, so we are conducting it today so that you can enjoy the day tomorrow and you are pre-aware that what tomorrow's day actually holds, what value it actually holds, right? So let me just share my screen. And before we proceed further, let me just quickly ask you this question itself, that what is the importance of National Science Day? Why do we actually celebrate National Science Day? So do let me know in the chat, and I will just hold up for a minute so that you all can answer. And meanwhile, you can see that there is a picture of a very famous personality indeed on my screen right now. So do let me know that who is this? What is the name of this personality? So does anybody have any idea? Who is this personality? So do let me know in the chat if you all have any idea. And meanwhile, today we are having the session live on both Spacetopia as well as on YouTube. So members of our Spacetopia community, of course, thank you so much for joining. And I hope you have joined through Spacetopia itself. But people who are joining through YouTube, we suggest you all join us through Spacetopia platform as well, which is our own interactive platform where you can find many more sessions just like this. And you will get to learn a lot about astronomy, space science, and other stuff through very fun and interactive, ways such as DIYs, live sessions. We conduct Zoom based sessions as well, where you can directly connect with us through Zoom, and we conduct various live activities, DIYs. We have quizzes, comics, ebooks, and many other stuff. So do make sure that you check out our website, our interactive platform, that is www.spacetopia.in. In the chat, we will provide you the link shortly. Okay, so I'm already getting several different uh, comments that this is actually CV Raman. So why? That is absolutely correct. This particular personality that you can see on my screen is none other than Sir CV Raman. But the other question is that why do we celebrate National Science Day? And there also I have got some comments is that CV Raman's birthday is celebrated. So while most of the people actually do think that it is CV Raman's birthday, which is celebrated on 28th of February, that is actually not true. His birthday is not on 28th of February. Instead, he did something much, much bigger and more important than just taking birth on 28th of February. And that is, he actually won the Nobel Prize in Physics, and he actually discovered the so-called Raman effect on 28th of February in 1928. So some of you are also commenting right now. I can see that he actually won the Nobel Prize, and that is absolutely correct. While he won the Nobel Prize in 1930, 28th of February was the exact date when he declared it to the entire world that he had actually proven the Raman effect. Okay, he had discovered it much earlier, but every theory actually needs to be proven, especially in science, so that it can be at least taken forward to the Nobel Committee. And that's what had happened. So, what is great about Sir C.V. Raman is that he was the first person from the entire continent of Asia. Now, I am sure that all of you are aware that Asia is the biggest continent. So, in the entire Asia, he was the first person to win the Nobel Prize in Physics. And that too at a time when we were not even independent. Okay, we were still under British rule. We were facing a lot of geopolitical problems, socio-economic problems, and among in between all this, he actually managed to grab one of the topmost prizes in the entire world. So that to honor his discovery, we actually have dedicated this entire day, that is National Science Day, to commemorate his efforts, not only in the field of physics, but in the field of entire science, that is on 28th of February. So we hope that you now have a clear idea that why it is actually celebrated. Okay. Now, if you look at Sir C.V. Raman's life, today's session is not going to be simply about Raman effect or a technical session. It's going to be a very generalized session where we are going to discuss a few important and very inspiring things about Sir C.V. Raman and how we can implement those things in our life. We are also going to see a brief about Raman effect. So we are going to have some interactive polls and an interactive game for you as well as we move along. So make sure that you are active throughout the session. So if you look at the childhood of Sir C.V. Raman, then from childhood itself, he was actually regarded as the prodigy of Trichy. Now, few people who might be from southern part of India, you might be aware what is Trichy or where is Trichy. So on 7th November 1888, he was actually born. Okay, so his birthday actually falls in November. Okay, and he was born in a small village in the city of Tiruchirappalli, which in short called as Trichy in Tamil Nadu. Okay, so after he was born, just at the age of 11, he completed secondary school. That is, he completed his 10th standard or matriculation just at the age of 11. So from childhood, he was quite, a prodigy. But it was not only due to his mind or brain, it was also because of the fact that he was extremely curious. He was extremely, he was extremely fond of asking questions. Whenever he found anything which was quite weird, he just simply asked, why is this happening? Why is that happening? How is this happening? He didn't think twice that what will people think of him when he's asking such questions? What will society think of him if he's asking such kind of questions? In fact, he used to even cross question his own teachers. Okay, so he has his own books as well. So you can read more about him in his biographies. But he was not only just a born prodigy, he was also curious, which is one thing that we should learn from his life. That is, we should be really curious and we should always be thinking in a way that we should ask questions. So we should be inquisitive, right? Now, at age 11, he's completed secondary school. And then after that, at age 16, he completed his bachelor's degree. So about 3 to 4 years earlier than the usual age when we complete our bachelor's degree. So he completed his bachelor's degree from University of Madras, that is called Chennai today. And 2 years after that, that is at age 18, he completed his master's degree, again 3 to 4 years earlier than usual people do. And that nowadays, at that time, usually at the age of 25 to 30, people used to pursue master's degrees. So compared to that time, he was extremely ahead of his own colleagues. Okay, so he was indeed a prodigy and he used to be very curious. He used to be very inquisitive. That is why he could actually achieve many of the things at a very earlier age. After he completed his education, he actually cracked the civil services and got selected as an accountant general. However, when he was posted in Calcutta, he used to lead a double life. During the day, he used to work as an accountant general, but he was very passionate for science, especially for physics, for experiments in physics. And that is why during the night, he performed experiments in a science laboratory, which was located in Calcutta at that time. That was the Indian Association for the Cultivation of Science, in short called the IACS. Even today, the IACS is one of the leading scientific laboratories in the entire country, situated in Calcutta. And from his life, we actually get to learn that if you're passionate about something, you don't wait for the right time. You just make time for it. We often say that we have a job, we have a business, we have XYZ things to do, and we are not getting time. Well, he used to work as a civil servant during the day, which is quite a hectic job in itself. And then he used to perform experiments. He used to, follow his own passion at night in the IACS laboratory. Okay. So in this way, he used to lead a double life. Because of his curiosity, because of his passion, he actually got a great opportunity to actually go to the Oxford University, which is again one of the oldest and one of the most highly regarded universities in the entire world. And when he was going to the Oxford, that is to the UK, at that time people used to take boats and ships to go. So when he was on the ship, he had actually carried a small pocket spectroscope. Okay, so people who might not know spectroscope, it is basically a device which helps you to study various colors. Okay, the various different types of colors which is present in our light. Okay, so you might be aware of the word spectrum. Okay, so it allows you to study the spectrum. So there was a pocket-sized version of that spectroscope which he had carried, you can see in the image. And throughout his journey on the ship, he was constantly observing this sea. And he just questioned, and it was a very general question indeed, is why is the sea blue? That was a very simple and straightforward question, that why is the sea blue? Why is it not red? Why is it not yellow? Why is it not some other color? Why is it just blue? And also, there was already some theory, existing theory as to why is the sea blue. So how about I take up a poll from all of you. You all can scan this QR code and go to this website, that is menti.com. If you scan the QR code with a mobile or tablet, you will directly go to this poll. But if you do not have anything to scan, you can just enter menti.com. You can go to this website. It will ask you for a code. You can enter this code 81254230 and it will take you to this question. So it is basically a word cloud where I want to know, you can just answer in one or two words. Why do you think that the sky is blue and not just purple or green? So I can see that some of you have already logged in. So, oh, that's great. So people are already logging in. So whether you are on Spacetopia or YouTube, you can either scan this QR code or you can visit menti.com. I will have a few other Mentimeter questions as well as we move along. So once you are logged into this website, just remain on this website with that device. Okay, so we have already started getting answers. So that's good to see because of the gases. Okay, let's see what other people have to say. I've already got 17 people who are online and you can see on my screen also. So let's just wait for some more responses as well. Okay. Now we will have further Mentimeter questions as well, 2, 3 more questions. So make sure that you do not log out or close your browser once you have answered this question. You can stay on that page itself so that you can answer the other questions also that eventually come up. Of course, if you have some work with that device or if you are taking a parent's device or something like that, you can again scan the QR code at that time. Once again, I will show the QR code, the link at that time, so you can get back the device. So I'm getting multiple answers over here. I'm getting light splits into blue. Okay. I'm getting some very fancy terms as well, such as refraction. I've got Rayleigh scattering. Okay. So I've got some nice technical terms as well. We are going to look into a few of them as we move along. So let me just wait for a minute more so that I can get a few more responses. I can see over 25 people are right now online. So come on, people, quickly just do not, there's no need to type long sentences. You can just answer in 1 or 2 words, whatever you think. Why is it blue? Okay, so we have got many answers. Light is made up of 7 colors, dispersion of light, okay, reflection of the sky. So, so few of the answers that you have given, such as Rayleigh scattering, reflection of the sky, are those answers that were already regarded at that time during those 1920s, 1930s, when people actually didn't know anything about C.V. Raman or Raman effect. At that time, that was the existing theory. Okay, so you all can keep responding in the same poll as I move along. The question will remain on your device. So let's just focus on the important question that actually changed the entire course of physics at that time. And that is, why is the sea blue in color? So, as some of you already responded, that was actually the existing theory. The prevailing theory was Rayleigh scattering. That is the reflection of the sky itself, because the light from the sky is getting reflected, so the water appears blue. And in support of that theory, Lord Rayleigh, who was actually a scientist earlier to Sir C.V. Raman, he had told that that is the reason that during the day you can see that the sea is blue, but at night it appears darker. That's because at night there is no blue sky, so it's reflection of the sky. So see how convincing that answer is. You can naturally think that, oh yeah, that's absolutely correct. We can definitely think about the fact that during the day the sky is blue, so we are able to see blue, and at night what happens is that the sky is dark, so we are not able to see, and it's very convincing to think, right? Why would you even question that? But still, Sir C.V. Raman actually questioned. His intuition was something completely different. What he thought is that there must be something happening on a molecular level. Okay, he said that there is something called molecular scattering that is actually occurring with the light. It's not like the light is simply reflecting off the surface of the sea or the ocean and you are able to see the blue color of the sea. It's not like that. The water is actually entering, it's penetrating inside the water, it's interacting with the water molecules, and there is some degree of molecular scattering that is taking place. He argued that water itself is doing something to the light. And that's what was the argument that he put forth before all the scientific minds at that time. But nobody was ready to believe, of course, because even if, let's say, I say that water is doing something to the light, you would naturally ask, prove it. So he then, once he visited London, he just made some contacts. And when he came back to India, he continuously, for continuous 7 years, he fought for the pursuit of proof. From 1921, when he got inspired from his Mediterranean voyage, because he was going over the Mediterranean Sea at that time, he observed it. After that, Till 1927, he was constantly performing extensive experiments, and he performed various different types of verification using very simple tools. Because at that time, we weren't even independent India. We didn't have much access to advanced technologies and tools. So he used simple tools such as lenses, prisms, and all that stuff. But what was important is that he had a lot of patience. And that is the next thing that we get to learn from him, that despite the circumstances, despite those challenges of that time, he actually had a lot of patience to play around with those tools, to conduct his experiment, to follow his passion, to believe in himself. Because there was this entire world who was saying that no, Rayleigh had already told, he was regarded as Lord Rayleigh, because he had done so great works, he was regarded as Lord Rayleigh. Lord Rayleigh had already told that the sky is blue and that is why the sea is also blue, but he refused to believe that. Finally, through his experiments in 1928, it was 28th of February 1928, when he actually confirmed through his experiments that no, the sky is not the reason for the blue color of the oceans. Instead, it is molecular scattering. It is something which I have termed as Raman effect, which is actually causing this to become blue. Okay, and that eventually, when he proved it experimentally also, that took him to the biggest prize in science, that was the Nobel Prize in Physics. So in 1930, eventually, when the entire world was convinced, he was finally awarded the Nobel Prize in Physics, and he became the first person from entire Asia to win the Nobel Prize in Physics. And he had told during his Nobel acceptance speech that scientific achievements do not require elite fancy laboratories. All they need is a relentless curiosity for learning. And that is one of the biggest learnings that we should actually imbibe, especially in today's world, where most of us are, surrounded by computers, technologies, AI, and all this stuff. And we often think that we need very sophisticated laboratories, we need very expensive technologies to conduct our experiments, to follow our own passion. But that is not true. All you need is a relentless curiosity for learning, and other things automatically get arranged. You will eventually get in touch with people who can arrange all those things for you. So this is how his life actually went forward, and this is how he became the one of the most well-known scientists of the entire world, from a prodigy of Trichy. So now, coming to the point, that what exactly is this Raman effect? So let me just quickly explain you the Raman effect in very simple terms, in terms which you can easily understand and which you can easily explain to anybody else. So just watch this footage carefully. In this video, what I'm showing is that there is a single ray of light, which I've called as monochromatic light. That means there is a single color of light. And let's say you have a sample. Sample means any kind of sample. Let's say any kind of substance. For example, it might be a medicine, it might be a drug, it might be any kind of chemical. When I strike a monochromatic light on that sample, some of the light will, of course, get transmitted, because none of that light will actually interact with the atoms of that sample, and it will just pass through the spaces between the atoms. So that is the transmitted light. Some of it will also get absorbed because of those atoms, but some of the light will also get scattered. Okay, because of the interaction with those atoms, because of the interaction with the subatomic particles, this light will get scattered. Most of the light will get scattered and maintain the same energy that that light initially had. That is why most of the light, that is in most of the incident light, will actually remain green, while some of the light will actually turn into either blue or red, depending upon whether they are gaining or losing energy. So let's say by interacting with the molecule of that substance, if it gains energy, then it will turn into blue color. That means the light will get shifted towards blue and it will become blue scattered light. While if it is, let's say, interacting with the molecule and losing energy, it will become red scattered light, and its light will actually turn, it will become red shifted. Okay, so this is what Sir C.V. Raman had actually told. He said that energy of the incident light is not equal to energy of the scattered light. The green light rays that you can see, the green scattered light, is the one which Rayleigh had said. So that is the Rayleigh scattering. But the color change is what was actually hypothesized and eventually proven by Sir C.V. Raman. He said that the energy change due to the interaction between the light and the molecule is what we call as Raman effect. And that energy change will be unique for every kind of substance or every kind of chemical. Why will it be unique? That's because, for example, you have, let's say, some other kind of substance. For example, you have water, and let's say you have a medicine. So water will scatter the light in a completely different manner compared to the medicine, who will scatter the light in a different manner. Let's say water produces two blue light rays after scattering. The medicine might produce one blue light ray and one red light ray. I'm just giving you an example, a hypothetical example. So just by looking at the change in the energy of the scattered light, you can determine which type of molecule or which type of atoms are present in that substance. And that is what was actually proven by Sir C.V. Raman. Okay, so over here, let me just show you a video. This footage actually shows you a substance where, again, there is an unknown substance containing unknown chemical compounds. And what I have done is that I have just shown you that if there is a single, again, monochromatic light going into this substance, most of the light rays, after scattering, they remain green, which you can see inside. But some of the light rays actually turn into red because of that interaction with the molecules. And those are the Raman scattered light rays due to the unknown compounds that are present inside. So by studying those light rays, by studying the wavelength, the characteristics of those light rays, the Raman scattered light rays, we can determine which kind of compounds are actually present in the substance. And this is not only limited to, this solids or liquids. It can even be applied to gases. For example, this particular closed bottle actually contains a gas. As I am removing the gas with a vacuum pump, what is happening is that, let me just play the footage. What is happening is that the light ray, which was not scattering in the vacuum, it is eventually scattering when it is interacting with the molecules of that gas. Again, you can see after scattering, most of the light actually remains green, but some of the light turns red because of the interaction with the molecule. It might also happen that some of the light may turn blue. In this case, it is turning red. So by studying again the characteristics of this Raman scattered light, we can determine the composition of this unknown gas. And that is how we can actually determine the composition of any known or unknown compound by studying the Raman scattered light, not by studying the Rayleigh scattered, because Rayleigh scattered light is majority in number. More than 99% of the light will be scattered in the Rayleigh scattering. However, there will be less than 1% that will be scattered in the Raman scattering segment. So that is what will help us to identify. For example, let's say you have a glass of water, you have, let's say, a particular medicine like a cough syrup, and let's say you have some kind of protein. This is how the signal for the water will look like. This is how the Raman signal of the water will look like. This is how the Raman signal of cup syrup will look like, while this is how the Raman signal for this protein will look like. So just observe that how different all these Raman signals are. If, let's say, you do not know that that particular substance is a protein, just by comparing the Raman signal to water signal and cough syrup signal, you can clearly identify that this is neither water nor cough syrup. Similarly, what we have done is that we have actually determined the Raman signal for all the known compounds, all the known elements that we have in our universe. So that is why just by looking at this particular graph, looking at this particular signal, we can compare it to the known graphs, and we can then determine what is the chemical composition of that particular substance. Because different molecules have different energies, and different energies will eventually lead to different signals or different Raman fingerprint. Just like our fingerprint can help us to identify us, this particular Raman scattering acts as a fingerprint for that molecule, and that is unique to that molecule. The Raman fingerprint that water generates is not at all same for any other molecule that is present in this universe. And that is why water signal is unique, this cough syrup signal is unique, this protein signal is unique. For each element, the signal will be unique, whether it's hydrogen, nitrogen, oxygen, whether it's some kind of metal, gas, solid, liquid, doesn't matter. Every molecule will have a unique Raman fingerprint, with the help of which we can determine that what exactly is the chemical composition. So just to give you a simulation, what I have done is that I've created a simulating game for you. Okay. I've created a simulating game for you. What you can do is that you can play this game. Okay, by scanning this QR code, we'll also share the link to this game in the chat. So you can check out the live chat over there. Also, you will find the link to this game. So you can play this game by scanning the QR code. In this game, what we are doing is that basically we have shown you that there is some kind of atom which is present, and through the atom you have to fire photons. Photons are basically molecules of light, so you have to basically fire light, and you have to see that how much of that light is scattering in Rayleigh way, how much of that light is showing Raman scattering, whether it's positive Raman scattering or negative Raman scattering. So what I'm going to do is that I'm going to show you this is how the game actually looks like. So once you start the simulation, you will have a timer of 60 seconds, and you can fire the photon. You can click on fire photon, and it will eventually fire, and it will show you if after interaction with that molecule or after interaction with that atom, is it showing Rayleigh scattering or Raman scattering. And it will keep on counting. Out of the total throws, how many are Rayleigh scattering, how many are Raman scattered. Okay. And finally, at the end, it will give you a Raman fingerprint as well, a hypothetical Raman fingerprint. So let me just do it along with all of you. So as we are proceeding forward with the time, So I'm showing you the QR code also, don't worry. Okay, let me just complete it and show it to you how it will look like. Okay, so I can see few of you. If you can scan the QR code, I will just show you the QR code. Just give me 15 seconds are left for this game. I just want to show you what the results will look like. So out of all the throws that I've made till now, you can see that some of the throws have actually shown positive Raman scattering, while some of them have shown negative Raman scattering. So this is how it will look like once you have completed. So out of the 35 throws, 30 showed Rayleigh scattering, 1 showed energy loss, while 5 showed energy gain. So my Raman fingerprint is 5G1L. That means 5 gained and 1 lost. Okay, so this is how it will actually look like when you play the game. So let me bring you back to the presentation. So here you can scan the QR code and you can play this game. And let me know in the chat that what is the Raman fingerprint that you are getting once you have played this game. Okay, so I'll wait for a minute while you all are playing it. Okay, I can see most of you have scanned the QR code and some of you are also joining through the link. That's good. Do let me know in the chat that what is the Raman fingerprint that you are getting. And the funny thing about this is that in the simulation, it actually occurs randomly. So most of each one of you will actually get a unique fingerprint, okay, unique Raman fingerprint. And that is the characteristic of Raman fingerprint. Every molecule or every situation will have a unique Raman fingerprint. Okay. So I'm already getting some comments. 3G2L, that's good. 3G1L. Okay. Now, kids do remember that this, although in this particular game, you can see that 90 to 95% is actually showing Rayleigh scattering, while 5 to 10% of your throws will show Raman scattering. In reality, more than 99% of the light actually shows Rayleigh scattering itself. It's just 5, it's just less than, 0.5, 0.6%, which actually shows Raman scattering. So that Raman fingerprint that we are talking about, we usually determine with the help of only those 0.5, 0.6% of the rays, which actually show Raman scattering. Okay. So I can see we have got 3G, 1G, 2L. So most of them, we are getting quite a good number of responses on the chat. So it's good to see. So the link is already in the chat. So if required, you can click on the link to play once again if you want to. There is no limit to how many times you can play. And every time, just see if you are actually able to get any unique Raman fingerprint, or you are able to get repetitive Raman fingerprint as well. Okay, so do let us know what is the Raman fingerprint of your molecule. So now that we have understood what is Raman effect, what Sir C.V. Raman is so famous for, let's quickly see that what are the applications of this Raman effect. In real world, how do we use this Raman effect? So this Raman effect actually has several very important and extensive applications in the real world. First is in the field of medicine and healthcare itself. Let's say there is some kind of skin cell or skin tissue, or let's say any other kind of tissue in our body, and we want to determine if there is some kind of disease or detect inside our tissue. So the traditional way is to just simply cut through the tissue and check if something is wrong. But with the help of Raman effect, we do not need to undergo any invasive procedure. We do not need to undergo any cuts or surgical procedures. Instead, we can use a Raman scanner and we can scan if the inside of the skin is perfect or not. If it is perfect, if the cells are healthy, it will show a nice signal. For example, this is how the healthy cell signal would look like. However, let's say there is some kind of tumor or cancerous cell that has developed inside that tissue. So what will happen? Due to that cancerous cell, due to that tumor, this healthy cell signal will get disturbed, and you will get a disturbed cell signal, for example, this cancerous cell signal. So by looking at that signal, you can determine that, okay, there is something wrong inside the tissue. So the doctor can determine, and eventually the doctor can then determine whether to go for any surgical procedure, whether to go for any other kind of process or something like that. And similarly, it has extensive range of applications in the field of medicine and healthcare. Another application, which many of you might have experienced also in real life, is in the airport scanners. So most of us might have seen that in the airport scanners, wherever the security personnel is sitting, you can see in his computer there are X-ray kind of things that you can see on his screen. All the objects are actually clearly visible on his screen. It's not just visually visible. Inside the scanner, there is also a Raman scanner which is placed, which can detect any kind of explosives or any kind of drugs or illegal compounds that you might be carrying in your luggage. So through that Raman scanner, they will be able to detect that. It will show on his computer that some kind of irregular or abnormal signal is getting produced due to this particular compound. And then what they will do, they will just remove it. Many times when you are carrying, let's say, talcum powder, when you are carrying very high amount of oil or some other compounds, they often stop you, they often keep your bag aside, and they ask you to open it up and show it to you. Okay, so this is what actually happens over there. The computer shows that there is some kind of irregular abnormal signal. It might be some kind of drug, it might be some kind of explosive, some kind of illegal compound. So just go out and check it out. So that's what happens in this case. Even in forensic science, even in forensic analysis, this Raman signal is actually used. So how about I take up another Mentimeter from all of you, and I want to know, where should we send a Raman scanner to find life? Because these are the Earth-based applications. On Earth, this is the kind of applications that we often have. What if we can send a Raman scanner to find life on outer planets, like on planets, other planets, on the moon or something? So where would you send? Would you send it to the red deserts of Mars? Would you send it to the icy shell of Europa, which is again one of the moons of Jupiter? Or would you send it to the thick clouds of Venus, which I believe you might know is the hottest planet of our solar system? So do let me know that what is your opinion? Where should we send our Raman scanner to find life? So I can see that few of you who have played the game later, you are also getting some. Okay, so somebody is saying that if we fire a monochromatic light through anywhere randomly through the air, can we still observe the Raman effect? Yes, you can still observe the Raman signal. However, you have to control the conditions, right? If you have a complete vacuum, you won't see any kind of scattering. That's what I was showing even in the video, right? Even in the video, I was showing that there is some kind of scattering which is happening only when there is some kind of gas or some kind of atom or molecule which is present. If there is complete vacuum, then there is no way that you will be getting any kind of scattering. Okay. So I believe that, okay, so I believe that almost all of you are online, but it still says, okay, if it is still showing the last question, let me just refresh it up and it will show you the current question also. Okay, let me just go back into the mode, and I believe it should now show you all this particular question. Let me just start the Menti. Yeah, so I've started it. So I believe it should now get refreshed on your mobile phones. Yeah, so all of you can now give your poll, and let me see that what kind of responses I'm getting. Let's see what majority of you have to give, what majority of you have to say when it comes to sending Raman scanners to find life. Let's see where most of you actually want to find life, whether it's on Mars, whether it's on one of the icy moons of Jupiter, or whether it's on the hot planet of Venus. So I can see majority of you are voting mostly for Mars and Europa. A small fraction is also voting for Venus. So I believe people who are voting for Venus, they are very fond of living in the extremely hot and dangerous conditions. I think they are not yet fulfilled. They are not yet satisfied with the hot temperatures, the global warming that is actually going around in our on our Earth, and they want to experience temperatures in the range of 200, 300 degrees Celsius by going to Venus. But yeah, even on the chat, I'm getting some responses that we would send it to Titan. Okay, yeah. So that is one of the famous moons also. That's right, Titan. But Titan doesn't actually have a much icy shell. So as of now, based on our current observations and theories, we have actually hypothesized that some of the icy moons, such as Europa, some other icy moons are also there. They might actually have contain life. So based on your responses also, I can see a majority of you have actually voted for the icy shell of Europa. And what's interesting is that you all are thinking in the right direction. So you all can keep voting. Scientists also have thought it in that direction itself. So first, as many of you might know, that we have many of our rovers and landers on Mars itself. So our we have a very famous rover, that is the Curiosity rover. We also have the Perseverance rover. Both of these rovers actually contain this instrument called Sherlock, which is basically a Raman scanner, and they use it to find life on Mars. Okay, they continuously scan the surface of Mars to find life. But after Mars, we are now targeting the icy moons itself. So Europa, which is the icy moons of Jupiter, Enceladus, again a very icy moon of Saturn. So below this ice sheet, we have theoretically proven that there might be signs of life. There might be aquatic organisms that are just developing below this thick ice sheet. So that is why our next target is actually to send such kind of landers and rovers to Europa and Enceladus, that is the icy moons, who can use those Raman scanners to determine. So without drilling holes, without digging into the ice, we will be able to determine if some kind of life is actually present beneath the icy shell by using these Raman scanners. So you can see the range of application of Raman effect all the way from the very basic, healthcare, forensics, and airport security till space exploration, till scientific research and astronomy as well. So that is the range of work, that is the range of application that Raman effect has. And that is the reason why Raman effect was regarded to be so famous, why Raman effect is regarded as one of the greatest developments that has happened in the history of science, especially in the history of physics. So let me just take up one more Mentimeter poll before we conclude today's session. In the year 2050, how will science have changed your daily life? Okay, and now I'm talking about science in general. So in the 1930s, Sir C.V. Raman actually proved the Raman effect, and the Raman effect was eventually applied in the next 50 to 100 years. Today, almost after 100 years, we have various different kind of applications, and even in the next coming hundreds of years, we will continuously have various kind of applications for the Raman effect. Similarly, how do you think just in the next 25 years, that means by 2050, how will science have changed your life? What is the big development that you are expecting will happen by 2050? So you have various options that I have put up, such as clean energy, smart food, time travel, and stuff. I know most of you are very excited by looking at science fiction movies and all this stuff, and that is why a good majority of people are voting for time travel as well. To be honest, as myself, if you take my opinion, I would keep time travel as one of the last options among all these options. I believe even talking to animals would probably be possible, but time travel I don't think would be possible by 2050. But let's see. This video is still on YouTube. So if I get proven wrong, then of course I will become famous by 2050. That this guy had actually told that time travel would be famous by would be possible by 2050. And now he said that time travel is there. But yeah, a good majority of people have also voted for affordable space tourism, which I also believe might become possible. Because currently, you might be aware that several different private space agencies and space companies have already jumped into this space tourism thing. And many companies, such as Blue Origin, SpaceX, and other companies, have jumped into space tourism. And they're already trying to make it affordable. So, probably in the next 25 to 30 years, it might become affordable. Affordable doesn't mean, of course, few thousands rupees, but affordable means that probably if a person wants to go for a space tourism at least once in his lifetime, he can probably afford it. It might come down to, let's say, like 10 lakhs, 20 lakhs, or 50 lakhs probably, which now literally costs hundreds of crores. Okay, usually the millionaires and billionaires have been able to afford space tourism. So probably that might be a possibility. Even Mars colonies has got significant amount of votes, which also I believe, at least if colonization is not possible, at least we definitely would have reached Mars, and we would definitely be at least setting up bases on Mars. So that might probably be possible in the next 25 to 30 years. Clean energy is something that is already a reality now. Okay, clean energy simply means that we are completely dependent on renewable sources, while currently in the entire world we are still dependent on non-renewable sources for the majority of the world. Okay, so there is a good possibility that almost the entire world will be relying only on, or at least more than 90% of the world will be relying on clean energy. Okay, and smart food is also something that astronauts are already trying to, develop. So probably scientists are trying to develop for astronauts. So that might be a possibility actually. Okay, so it's good to see that I have a variety of opinions on this, and let's see in the next 20 to 25 years what actually becomes possible out of all this. So let's come back to Sir C.V. Raman's story. So what we ultimately learned from his life, from his achievements, he did not have access to any billion-dollar laboratory. But yet he did not stop asking the curious questions. He didn't think what people will think, what society will think, whether my friends or colleagues will think that I'm crazy, or I'm mad, or I'm just, foolish. He just asked the simplest questions. Just imagine what was his question. Why is the sea blue? How silly that question actually sounds. Just imagine you are going to the beach tomorrow and you are just saying, you're out loud shouting in front of everyone, just tell me why is the sea blue? Especially considering that there was some great scientist who has already proven why is the sea blue. Still, he asked it. So he countered the existing concepts, the existing theories as well. So essence of science is independent thinking and hard work and not equipment. Quote from Sir C.V. Raman himself. And since he didn't give up until he proved his theory, we should also not give up until we prove what we believe, until we achieve our own ambitions. And to take forward his legacy, in India, we have created several different types of research institutes, universities, even certain fellowships and awards in his name. And you can have a brief overview of all these different types of, things that we have established in honor of Sir C.V. Raman, simply because of the fact, not only due to the fact that he discovered or proved something, but also because of the fact that he did all this at that time when we were not even independent. We are having so much amount of geopolitical issues. We are having socio-economic problems. Many of the people in our country were not even getting enough food. And at that time, he was thinking so ahead of his time, so ahead of his contemporaries. So it's something that we should learn and something we should get inspired from. Okay. So I believe that with this, you all now have a good idea, a clear clarity on what exactly is Raman effect. Why do we celebrate the National Science Day? What exactly Sir C.V. Raman did that made him so famous? And why this Raman effect is so important? What are the variety of applications that this actually has? So thank you all so much for joining with his story. Let's hope to keep our curiosity alive. Let's hope to keep your inquisitiveness alive and active always whenever we are learning something, whether it's in school, college, in any kind of session like this, or anywhere, be it anywhere. Never fail to ask questions whenever you have. Never fail to, uh, cross question anything that you feel might be incorrect, and never give up until you have achieved what you want to. So with that, thank you all so much for joining. We hope to see you again in the next one. Till then, goodbye, good night, and wish you all a very happy National Science Day. Thank you so much.